So we'll be starting with just a very quick introduction to Neo4j, who we are and what Neo4j is all about for those perhaps who are not familiar currently with Neo4j. Then, as I say, we'll take a look under the covers at how you would use Neo4j to handle some of the data management challenges that come along with GDPR, including data lineage, data governance, data security. And then I'm going to hand over to Will Parton, who is from our customer and partner TrustUp. And TrustUp offers a privacy by design software as a service platform, which supports the flow of personal data across organizational ecosystems, and is also being used very successfully to provide compliance, GDPR compliance. We'll have some ideas about possible next steps on your journey towards GDPR compliance and how Neo4j can help. We'll talk about those at the end of the presentation. So very briefly, a few words about Neo4j, perhaps for those who don't know it. So we are a provider of NoSQL database technology. We are kind of on the same bus with many of the NoSQL providers and some of the big data providers, in that we point to the fact that data is increasing in volume, it's proliferating, it's coming at us through an ever-increasing number of devices and number of channels. There's more of it day by day and hour by hour. Where we kind of stay on the bus and some of the other vendors get off the bus is that we point to the fact that it's also becoming more connected. And the connections between data entities are themselves, can be themselves as important, or even more important than the data itself. So what Neo4j provides is a way really of handling and taking value from not simply the data, but also the relationships, the connections between data. Neo4j is a graph database. It's a way of handling complex interconnected data. It is commonly used where you find highly interconnected data, and that means that it tends to be used for applications and platforms including real-time recommendations, fraud detection, master data management, of which GDPR compliance is an example, identity access management, graph-based search. You can find more information about these other use cases on our website at neo4j.com. And just a way of thinking about how you would use Neo4j or a graph database, well, it's like any other database management system. You typically start by modeling your data as a graph of entities and relationships. But unlike a relational database, for example, it allows you to store the relationships between the data elements as equivalent first-class objects within the database. So these relationships themselves can have properties, can have behavior, and you can use that information about the relationships between data entities to really transform your business, take advantage of the power of that to add new capabilities. And what a lot of our customers and users find is that you can very dynamically add relationships to existing data on demand or on the fly. As new data sets become available, you can add them to the existing live graph, and the system becomes more powerful. You can gain more insight into the way your customers are interacting with your website, for example, or your various services. You can take advantage of new data sets as they become available to gain new insight. Just a couple of high-profile use cases, perhaps just to give you a flavor. Along the bottom there, you can see a number of our existing customers, and they really do span the whole market. So there are investment banks, retail banks, there are global retailers, there are e-commerce companies, there are equipment manufacturers, all of whom are using Neo4j actively today. On the top left there, you'll see NASA. NASA uses Neo4j for a very extensive knowledge management platform, tying together data across a large number of siloed data systems, so that they can fully exploit all of their research that goes back across many decades. NASA believes that their use of Neo4j has saved has saved them 2 years in the development of the Man to Mars program, simply by linking together all of this research information. In the center there you have the Panama Papers. Some of you may be familiar with that. It was an expose, a journalist's expose last year, which uncovered the connections between many well-known figures and politicians and their offshore bank accounts. The journalists used Neo4j in order to analyze the data, uncover these connections, and really take advantage of the power of this technology to manage complex and interconnected data and uncover relationships between them. And this is a pattern that we see occurring over and over again. We're here today to talk about GDPR in particular. So for those of you who may not be so familiar with it, here's a brief summary. It is a European Commission, European Parliament directive. It comes into effect May the 25th next year. It's really about empowering all of us as citizens to have better control over the way that commercial enterprises and companies use our data. It brings with it a whole set of new rights and responsibilities, including the right, for example, to be forgotten, so that you can direct a company that uses your personal data to delete it completely and to forget all about you. You now also have rights to ask how the data is being used and where the data is being used, and you have a right to know when the data has been abused, when there's been a breach of privacy, for example. And all of this brings with it significant new implications and responsibilities for any organization that collects personal data. And there's a list of some of them there on the lower left side of the screen. What we'll be talking about today is how a graph database can help to manage some of these challenges, to make some of these responsibilities possible and practical. And GDPR itself it's a very significant piece of legislation. It comes with it, for example, it comes with the right for authorities to apply fines to organizations who breach the regulations, and these are very significant, amounting to perhaps 4% of global turnover or 20 million euros, and that's for each instance of the breach. So there are very, very significant, very severe implications for breach of data. There's also a time pressure. Organizations will need to notify authorities in each country and their customers or users of any serious breaches of data security within 72 hours. And we're also seeing that there is a requirement now in organizations to appoint a person with significant authority to be responsible for ensuring compliance with the legislation, a data protection officer. And these responsibilities transfer. So in the modern world where you may be working with cloud service providers or security service providers, there is an implication now that the responsibility for data breach doesn't transfer. So if data is shared with a cloud provider, the responsibility for ensuring the security and safety of that data remains with you as the organization responsible for managing that data. So all of this has very big implications for how we manage data, for data governance in particular. And here's a very high-level summary. So, for example, when asked to, an organization has to be able to track down every reference to an individual that they may have in their possession, and that, of course, applies to personal data, the obvious personal data that all of us might be concerned about, names and addresses, dates of birth, and what have you. But it also can apply to every contact, every social media piece of data, every tweet, for example, that a customer tweeted about your product or responded to, potentially every entry in a log file, every part of your website that a customer or a user visited. All of this lies within the personal data that is affected by this regulation. And so it's a big requirement now on organizations to be able to maintain the entire context of a user or a customer, to understand how they interacted with your website, and to be able to track down all of the information that relates to them. The information has to be consistent, and of course then there at the bottom you see that there are some obvious requirements for compliance that will have to be introduced, including how do you identify all the related data across all your different data silos. How can you understand where data entered your organization and how it was used and transformed? And how can you understand all of the context, as I say, all of the data that you might have on a particular customer? So here's a set of questions. I won't go through them today. I'll leave them to your leisure. But here's some questions to start with about how you would assess what you have to do and where your exposure is to the GDPR legislation. This is really the beginnings of a roadmap for how you would understand the scope of what you have to do and how it's going to affect your systems and the way that you operate today. And we also can lay out a guide essentially for how you would get to GDPR compliance. It's going to start with implementing or refining your existing data governance platform so that you can answer questions about how many people, for example, have exercised their rights under the legislation, how much new data has been added over time. Can you account for what are called CRUD operations, so creating, updating, deleting data. That may even apply to your backups, for example, your archives of data. Your DPO is going to need to be able to have up-to-date information on compliance and on risk and exposure. So that often brings with it this a requirement to provide a dashboard of some sort. And users themselves may need a way to interact smoothly and cleanly with you to ensure that they can exercise their rights under the legislation. So that may need a portal or a programmatic interface for your partners and suppliers. So how does this all relate to graphs? We at Neo4j, we're seeing a very significant adoption of Neo4j to handle GDPR and data protection responsibilities, and that's across many industries. And the reason for that really is that Neo4j has this direct, innate ability to manage both the data and the relationships between the data as equivalently important. And that makes it very easy to define and to model the relationships between all your personal data, wherever it may be across an enterprise. And it allows you to model very diverse forms of data and to deal with the fact that different users and different customers may have different data profiles. The other principal benefit is that graph databases such as Neo4j can react to patterns, so they can spot when a particular relationship is broken or when a particular risk arises, and they can flag it up. They can spot that it's happening and make relevant persons aware of it in real time and on demand. So this introduces the ability really to dramatically reduce the risk that may arise as more and more data becomes exposed to the regulations. So at this point, I'm going to hand across to Dr. Jesus Barraza, who's a member of our consulting team, and he's going to take us through a worked kind of example of how a graph database can very specifically solve these problems. Jesus, over to you.
Thank you very much, Anthony. Let me quickly move on to my slide deck. Right, so my plan of the next 20-25 minutes is to go over these 5 points. So I'm going to try and describe what a graph database is, what are the most common use cases, and then focus on how is Neo4j being used to support GDPR initiatives. I'll do a very, very brief demo and conclude with a few takeaways. So what's a graph? I mean, a graph is a way of representing data, right? For many years, data has been very predictable. It's been stored, has been collected, has been used in very predictable ways, and for that, the relational model has been useful and the sort of the right way to deal with data. But we see that these days data is a lot more variable. Data is dispersed. Data is fragmented. It has different shapes, and these shapes can change over time. So the relational model is falling a bit short, and that's where all the NoSQL alternatives are becoming useful, are coming into play. And in particular, the graph database, being one of them, provides this support for these changing requirements, for these changing shapes in the data and in the uses of data. But again, trying to answer the question, a graph is I'm going to focus on the property graph, which is the way in which NEO represents graphs, is just a set of data points, right, that are connected to other data points. And that can be as simple as a road with information about lights and incidents associated to each light, but it can also be a hotel with information about rooms and availability, or the most popular one, the one that we're all familiar with, social networks, professional networks, people connected to people because they either know each other, because they work with each other. What they all have in common in this labeled property graph is the fact that nodes are described by a number of properties, as we call them, but the same applies to relationships, and that's an important and differentiator of the property graph model, because that enables possibility of adding things like metadata, things like information about the connections themselves, which we're going to see that are very, very useful in the context of GDPR. And relationships and nodes both are typed. But the interesting thing about graphs is that they can grow organically. I mean, we can keep adding nodes to our graph, and we can, for example, extend it to include the fact that individuals have worked, have studied at a particular institution, or that have worked at a particular company, and we don't have the same rigidity that relational model or schema strong models impose, where there is a whole migration every time data shape changes. So in a graph, it's a kind of a natural thing to add new bits of information and extend the graph by just adding new nodes connected to the existing ones. So by adding elements to this graph, we provide a platform that can bring significant value, because graphs will grow at very large scales, and we're talking here about millions, if not billions, of nodes that can be held in Neo4j. So why it's important and why looking at data as a graph brings immediate value? Let me show that to you with a very, very brief example that I'm sure will resonate. So let's look at this small data set. It's an Excel spreadsheet that I'm sure we all have worked at some point in our lives. And this one in particular is representing probably something like data, money transfer between individuals. So we have a 4-column data set where we have individuals in the from and to columns. There's an amount and a timestamp. So that probably represents the fact that A is sending money to B, C to D, etc., etc. So the typical analysis that we've been doing for so many years on this kind of data is doing aggregations and with aggregates building things like the bar chart that you see on the right-hand side, pie charts, and finding, for example, who's the highest sender, the highest receiver, what's the average, etc., etc. But if we take this data set, and that's why I'm asking you to look at it as a graph, and we just bring it into Neo4j, the obvious translation, the immediate translation is that nodes representing individuals, and each arrow represents a money transfer. So we immediately see some patterns emerging, some patterns that were not obvious from the previous way of representing the data. And we see that there's actually 2 communities of users, right? So we can see that to the right we have a smaller community that does not interact at all with the one to the left. So and they have different shapes. So we see that the right community to the right-hand side has a player in the is a centralized community, basically, because all the transactions seem to go through a central node, which does not seem to be the case on the left one. But there is a another interesting case, the fact that there's two sub-communities. I mean, these are all structural patterns that emerge when you look at data as a graph. And we can think of applying graph algorithms to find things like clusters, like rings, like between centrality, and get a lot of value that was not obvious when we were looking at it in the traditional way. And there's a number of companies that I'm sure you're familiar with that have done this over time, and I would like to mention just very briefly a couple of them. So if we think of what web search was a few years ago, 15 years ago approximately, basically it was all about indexing the content in the web and then offering a search interface that would determine, based on the keywords that you were using for searching, what was the relevance of documents. And well, there's a number of ways to determine what the relevance of a document is based on the number of search terms, the whole area of information retrieval. But what changed the game completely was Google's approach, and they thought that they were not actually looking at just isolated documents, but at connected documents. So the web pages were actually related to each other through hyperlinks. And they thought that the relevance of a page, the authority of a page, could be determined by the fact that many other pages are linked to it, right? And that this authority, this relevance, could be propagated transitively, which means that if a relevant page, if an authoritative page points to another one, it propagates a more weighted relevance. So these of course, changed and well, we know the story, what happened. So this is at the center of the success of Google, and all they did was thinking about data as connected points, as a graph. Something very similar happened in the web search space with LinkedIn. If we think how before LinkedIn job searching was it was basically a definition of a job opportunity in terms of a number of parameters, and then again based on some search, we would return the most accurate matches. But what LinkedIn thought is, well, actually, when you're looking for a job, if the first thing you will do is contact your ex-colleagues, the people that you worked with, the people that you meet with in meetups, the people that share interests with you. So there's this notion of a professional network. And as opposed to the Google case where the hyperlinks, the connections were already there, they asked the users to contribute these connections, to tell who they knew, who have they worked with, what were they interested in. But again, they shifted from this discrete analysis of documents, of job opportunities, to a connected environment where connections between individuals would drive things like the recommendations that we get regularly from LinkedIn. When LinkedIn recommends us to connect with someone, it's probably because we have a number of things in common. From the point of view of the graph, there's a number of indirect connections between us as nodes. Well, these are just two examples of companies that have been extremely successful, that have become leaders in their space by changing in the way they looked at data. Something very similar happened with PayPal, but the idea is that, well, these companies over time they develop their own graph-based solution. But what Neo4j brings is an off-the-shelf graph database where you can bring your data and derive immediate value out of it. And we see that Neo is being used these days in practically every industry, right? So government, healthcare, retail, etc. And the use cases, I won't spend too much time on them because they've been mentioned briefly by Anthony, that we see more frequently are around fraud detection, like trying to find unexpected or unusual, potentially fraudulent structures, but keeping in mind that we look at it from a structural point of view, rather than looking at individual transactions, for example, and try to find outliers, which is probably the most naive or the simplest to implement approach to fraud detection. What we're looking for is more sophisticated structures where nodes are connected to other nodes in ways that are unusual or that are suspicious. Something similar happens in retail recommendations, where by making explicit a customer's shopping behavior or adding to the graph things like the product catalog, the relationships between products, we can provide, and by exploring the the graph around a particular user some highly relevant recommendations for products. Network and IT operations, well, networks are by definition a set of connected entities, so we modeling them as a graph and then exploring them to analyze dependencies and derive, for example, things like impact analysis or root cause analysis is something that we see Neo4j being used for. Identity and access management is another interesting one. The more assets and the more complex organizations, I mean, keeping a real-time view of who has access to what is a challenging problem that graphs solve in a very natural way. And finally, master data management, or probably more like customer 360 view or product 360 view, is another case where the flexibility of the graph makes it very easy to import data from different sources, connect it, and have a single unified view. That kind of has to do what we're going to see in a minute around GDPR, as we're going to see. So let's go to the center of my presentation, which is how graphs can bring value in support of GDPR compliance. I'm going to look at four examples of graphs, and hopefully I'm going to try to give you a couple of examples in a sort of mini demo form about them. So the first one is data modeling and definition. The second one is data lineage. The third is consent management, and the fourth one is entitlement. Let's look at what I mean by each one of them. The first one is data modeling and the data definition. So depending on the maturity of your organization, you will probably work with things like data glossaries, with concept vocabularies. In the more advanced case, you would have some things like enterprise ontologies. And the idea of these glossaries, these concept sets, are to be able to tag your data at the logical level, but also at the physical level, in order to then be able to trace back how your customer information is being used and which systems hold customer information or product information. So this sort of, we can call it lineage in a way, but it's this traceability of these enterprise ontology concepts and the physical and logical elements is extremely valuable in the context of GDPR, especially, for example, for the case of trying to identify where does your customer data live. And we're going to see that in a query that's clearly not a tabular problem, so that's a scenario that can easily describe, well, easily, it's a complex model, but can be naturally described with the graph, so we can see how a customer or a property in your enterprise ontology of this customer translate into a logical model, and then ultimately is used to generate a physical model, a relational model, or an application model. So this model, the interesting thing in a graph is that it can be not only explored visually as we're doing here, but it can also be queried in a structured way, and the results can be presented in a machine readable format, which we're going to see that it's a very important requirement from the point of view of GDPR. Second one is data lineage. So we want to see how your data moves across the different systems. So we will this data lineage can be defined at different levels of granularity. It can be defined at the business level, so we might want to know how the critical data elements flow, let's say, between systems. So we can say that the billing system is sending transaction dates to the enterprise data warehouse. That's a receiver of this critical data element. But we can be more granular and say, for example, that how the process of bringing data into the data warehouse actually takes place, and ultimately maybe how does it populate reports or dashboards. So what we see on the bottom of this diagram is how data from a relational schema, from a data store, from an operational system, we can see a schema with the table and the columns, how these columns are being used through some kind of middleware, maybe it's an ETL system, how these elements are combined or aggregated to produce an aggregated view in a data warehouse, and maybe ultimately used as part of a dashboard or a report. So this horizontal traceability, this data lineage, is something, whether that's in an analytics space or more in a transactional space, is something that can be modeled in a natural way, again with graphs. The third graph in GDPR is consent management. And if that has a bit to do with this notion of customer 360, or well, sort of tangentially with master data management. But if we think of a graph view like the one you have on the screen, where we have a central node representing a customer, and then around it some nodes representing the information that we have about this customer, that node represents me, and we can have, I mean, I might have shared my personal email address with the organization, and I've given you consent for specific use cases. So that's where the value of these properties in relationships can be useful. That's one example of how this can be modeled. So we can express in the graph how and when this data, when did I give you consent to use this data, eventually a reference to the document with the terms and conditions, and what are the allowed use cases for each of them. And we can do that for every piece of information that you hold on me. You can have multiple email addresses, telephone numbers, etc., etc. So, and finally, the last one is entitlement. As I said before, being able to keep an accurate view on who has access to what when your assets are organized in a complex way can become complicated and can become tricky, especially when you want to apply exclusions or exceptions. And in this example, we see, for example, how user 1 and 2, because they're members of group 1, they have all access to resources 1 and 2, create, update, delete, etc. But there's an exclusion list that removes deletion rights to user 1 specifically. So rather than having to create another group, we can easily in the graph accommodate this notion of an exclusion. That's just a simplified example, of course, but shows how the graph can accommodate and can model this kind of sophisticated or more advanced ways of describing who has access to what. And again, coming back to the idea that I described at the beginning, the interesting thing is when these 4 graphs that I described, or even more depending on the use case, can coexist together and all live in a store where we can derive value from it. And that's what I'm going to try and show with a very brief demo. Let me bring Neo to the front. Good. So I hope that's visible. What you see on your screen now, it's is the developers or the analysts front end to Neo4j. So this from this front end, from this interface, we can interact with the graph database. We can run queries. We can visualize what's in the graph. And in order to do that, we're going to use the Cypher query language. The Cypher query language is a pattern-based, is a sort of ASCII art-based query language that we can use to query the graph. And if you, bear with me just a second, what this query returns, well, first of all, what this database contains, and I want to do that quite briefly, is well, it's very much the kind of graph that I've described in the previous slides. So we've collected data from, for example, from data governance solutions, from middleware components that expose information about data lineage. We've included also data about schemas, database instances, what's their structure, what are the tables, what are the columns, what's the level of confidentiality of each of them, and this is all aggregated in a single graph. So what we see in this visualization, I'm navigating from concepts, and we're talking here about what I call the enterprise ontology, how these concepts are translated into logical entities and ultimately into physical entities in a relational database. So if we take, for example, an address here on the left-hand side, we see that it translates into some logical attributes that ultimately generate a number of columns, which are the green nodes, in relational tables that are stored in database instances, right? So this whole vertical lineage is what we were seeing in the first of the graphs of GDPR. But what's interesting is that we can query. I mean, it's not just about visualizing the graph, which can be intuitive in some cases. But if you think of a large-scale graph, probably that what you will do is run queries like, well, give me all the database instances, and we can produce a tabular report like this one. Or probably more interesting, we want to know all the systems that are holding some customer names, right? Customer name might be a confidential information that we want to keep track of, and we look for a specific concept, which is customer name, and we navigate exactly the same structure of connections that I described in the previous query, and we can say, well, how is customer name being used in different systems, right? So again, we start from the ontology, and we see that it ultimately is stored in a ERP system in the table called party, and specifically in two columns, in party dot last name and first name, right? So that can be explored visually. But maybe what we're interested in is in finding out where does this data live geographically. Let's say we want to build some kind of GDPR dashboard, and we want to know, well, that's fine. Where does the ERP data physically live? Well, we can find where the different servers or the storage system, what's the name of the data centers, and what's the country where these elements are physically installed. So you can see that the graph makes it possible to combine visual results with more tabular results, typical dashboards. Just to conclude, we can return the same version of the query on customer name, so we can easily run a query that produces as output the location and the systems that store customer information, in particular the customer name here. Let's move to the consent use case, and I want just to run a couple of queries. One way in which we can represent multiple sources of information. Let me just make it look a bit nicer. Oops. It's not liking it anyway. So we see that there's a central node representing the master, the unique identifier of a customer, pretty much what I described before, and we have a number of pieces of information about it. But for every single one of them, we can have this user has shared with us his email, and he's sharing his email for use cases 1 and 4, and that was shared with us on that particular timestamp, because sometimes this is limited in time. So we have this level of granularity, and we can either explore it visually, or we can run a query like this one, where we are saying, well, what are they? What's the information in our dataset that I can use compliantly for use case 1? Right? So I can just filter all the information that has been given, shared with us by customer for this particular use case. And well, we can produce again a tabular result like this one. And again with this, I'd like to touch on the right to data portability. We can get the request from a user to give me all the information that you hold about me. And I'm going to put that in a tabular form. We can get for Mildred Jones, based on his email or any means of identification, we can get the list of all bits of information that we hold on her, and that can be exported in a machine-readable format, which is another of the GDPR requirements. Good. So I think that gives you an overview of what Neo4j is like, how do you interact with it. And with this, I'm going to hand over control to Will Parson from TrustUp, so he's part of the presentation. So there you go. So you should be able to take control now, Will.
Okay. Thank you very much, Jesus. And, hopefully now you can see my screen. Great. So Will Parton, I'm Chief Technical Architect of TrustUp. I've got a few slides here and then a demonstration to run through. So quick overview of TrustUp, what we are. GDPR, just to run through some key themes within the regulation and a couple of unexpected bits of impact, just to get you thinking about that. And then really, how do we use Graph to start your GDPR journey, and what solutions do we have to address that? So I will run through that set. So TrustUp, we are a SaaS service provider, we're not GDPR consultants. We have a number of SaaS services that help you with data privacy. Obviously, our focus is GDPR at the moment, but we're broad on that. We have two key products, Privacy Lens, which is a data privacy lifecycle management tool, allows you to understand your privacy data, your data within an organization, identify where you've got problems that need to be resolved under GDPR regulation or the data privacy regulation. And then we have Privacy Hub, which is a set of modules that will address some of those issues. So if you need to encrypt data, if you need to obtain consent, if you need to engage with your data subjects, one of the Privacy Hub modules might well be something that you would use to do that. Graphs are at the heart of both of those. Neo is at the heart of both of those. This presentation is very much looking at the Privacy Lens, is the start of the journey for GDPR. I won't cover so much the back-end systems. So GDPR, it's a big regulation. It's 200 pages of recitals and articles. I just want to bring out a couple of sort of key themes here. What is GDPR trying to do? Well, one of the things it's trying to do is to turn back the clock on an individual's control of their personal data. So in the UK, at least, the current Data Protection Act was written in 1998. It's obviously getting a bit long in the tooth, and it was written in a very different environment, both from a technology and a data perspective. So going back to 98, cookies existed. Netscape had, created those sort of 3 years prior to that, but they're collecting very small amounts of data, basically just tracking whether you've visited a website before or not. The smartphones don't exist until 2000. The iPhone doesn't appear till 2007. Big data does exist. So John Mash's paper was written in 98, but it's talking about 3.5-inch disks and sort of low gigabytes of data. So big data has got some growing to do to what we've got today. Google Analytics doesn't exist. So you get the idea. There's a lot of technology has moved on from 1998 when DPA was written. DPA, the control of your privacy data at that point in time essentially was down to the technology of the day. What GDPR is trying to do is wind back the clock to give you, the individual, that same control of your personal data. This time it's not through technology, it's through regulation. So there is a real driver for GDPR to achieve that, and that flows through the regulation. The other piece of the thread I'd like to highlight is this concept of privacy by design, which is dotted through GDPR. What does that mean? Well, it's at its simplest, it is think early in the process about privacy. There was a security by design initiative some years ago. It's the same thing for privacy, but this is not just a technical gig. It's broader than that. So it covers things like process and potentially culture. So for instance, if you have a bunch of customer sales representatives sitting in front of a CRM system, taking calls from your customers, they are recording information into that system. If they've had a bad call, the information that they record can be, let's say, derogatory in some cases. And that all gets recorded into the system. Well, why does that matter? That matters because under GDPR, if you get a subject access request from one of those individuals to say, please release your data to me, that includes all of that information that's held in the CRM system. So all of a sudden, that information that up to now has been private and been internal into the organization is now out there in the public domain. It's been spread around by social media. So there is a cultural shift that needs to happen in order to address some of these issues. It's not just a technology gig to address GDPR and the regulation. So there's a couple of themes there that I think are worth highlighting. There are also a couple of side effects of GDPR, which are not intrinsic in the regulation itself, but are a result of that. One of which is there's a massive change in the cost-benefit model for holding personal data. So under Data Protection Act, there is little cost to holding personal data, and there is a lot of benefit. That's why companies collect a lot of data and then use that to mine. Under GDPR, that's changed. For the much highlighted fines come in, so it's £500,000 under DPA and 20 million euros under GDPR. But also things like the cost of managing consent for the data that you hold. So have you got the provenance for the data you're currently holding? Can you prove it? If not, have you got to reconsent? Have you got privacy insurance for your data? Can you get insurance for the personal data that you're holding? That cost-benefit model has changed to the point that the processes you are running today may no longer be cost-effective under GDPR. So there's a whole issue there. Before you start throwing a GDPR privacy regulation blanket over what you're doing, is you need to assess your existing business processes to understand whether they're still actually viable and cost-effective under GDPR. And the other side effect is that data privacy needs to be understood by a much broader audience than previously, both within an organization and externally. So you have got to prove to your customers that you are doing what you need to. You're taking the technical and operational steps to protect the privacy data that you're holding. Well, how do you prove that? How do you show that? How do you demonstrate that? You've got to convince your insurance company that you are taking those reasonable steps. Again, you've got to share that information. Within the organization, you've got to gather privacy data from a much broader set of actors within the organization, and they have to understand the whole context. So you need the ability to convey privacy information to a much broader audience, and it's no longer just the DPO and the CISO or the CIO that's interested. It's individuals that don't have an understanding of privacy, and they need to understand that information in the context. So there's a side effect there that I will cover once we go into the demonstration, how TrustUp addresses it. So achieving GDPR compliance, where do I start? So TrustUp, we have the privacy lens, which is our lifecycle management tool. Within that, there is an abstract model. At the heart of that is what we call personal data in the 4 Ps. So you have personal data within your organization held in various repositories. That data interacts with the 4 Ps. So those Ps are the processes that either consume, use the data, or generate that data. The platforms, both logical and physical, upon which that data and the processes reside and running. The people within the organization that interact with that set, so who's running the processes, who owns the processes, who owns the data, so there's an interaction there. And then finally, places, so physically where does all of the above reside, and that's important because of things like jurisdiction under GDPR. So what you're seeing here is nodes and relationships, so you start to see, okay, why a graph sort of fits into this environment, and that's very much at the heart of our privacy lens is a NEO graph that instantiates these entities, but also a broader set and the relationships between them. The process that we run through is that first step is a discover stage, and essentially we call it know your data. So the first part of your GDPR journey is to understand as an organization where is the data you're holding, particularly the personal data, what is interacting with it, what is that data, what is the data set. So there's this discovery phase as a first phase. There is then a set of follow-on steps, so there's an optimization phase, and this is where that assessment of is what I'm doing today as a process actually the right thing to be doing. I need to look at it, and there's potentially a business transformation phase to do that process optimization or data optimization. Before I then move into a compliance stage and look to see, okay, what do I need to do in order to achieve regulatory compliance under GDPR or any other data privacy. And then ultimately you get into a sort of a more BAU role where actually I'm just managing data privacy. I'm looking at potential breach management, risk management, that sort of thing. So the privacy lens within TrustUp is very much in that early phase. Ultimately, some of the other modules may come into play in the compliance and management steps of this process. Graphs are at the heart of two of our main modules. So as I said, NEO is at the heart of the privacy lens, and I'll cover that in a minute. You'll see the demonstration, you'll see the visualization that is presented by the graph. But we also have a protect and store module, which is an encrypted vault, essentially, with data and relationships between it. So again, we have NEO in there. they're very different use cases. In the privacy lens, we're doing things like analysis of the data and of the relationships. In the privacy hub, all of that data is actually encrypted. We don't have keys or access to it, so it's very much more a way of holding data and relationships between them without actually knowing what that data is. So time is a little short, but I will drop into a quick demonstration. So let me bring up the privacy lens. So sorry, we've just rebranded it from business lens to privacy lens. So the privacy lens has 3 tiers. What we're looking at here is a configurable dashboard with a set of widgets that you can select. Sitting behind here is a Neo graph, which is modeling an organization in terms of its personal data and the 4 Ps. This data is being summarized in this summary view, and this typically would be tailored to the viewer. So if this is a C-suite person logging in, really wants to know whether, is the company red, is it green, have I got a problem as far as data privacy is concerned? If it's the DPO, I want to go down to much finer level of detail. If it's somebody who's responsible for a particular process or particular set of data, then they want to just focus on that. So this summary dashboard just gives you some ideas as to what is within the model. The engine room of the tool is the visualization. So this will obviously be familiar to you if you're familiar with graphs. So we model here personal data. So this is a personal data entity, the processes that relate to it, logical applications, roles of people, and the teams they reside in, physical places. So you start to see what's here. This is dummy data, and it's an example enterprise. But you already see that actually, even with a small amount of data, it gets quite complicated. So we need to be able to refine this. So actually, if we decide we just want to look at the business processes and the personal data that are within this organization, suddenly it gets a bit clearer. Actually, this business has got 3 processes. It's got a monthly customer billing process, a marketing campaign process, and a monthly payroll process, each of which either generate data in or use data in a number of data stores. So actually, it's not that complicated. Having captured the organization within the model, you can then run analysis against it. So, for instance, if I wanted to know where am I running a process for which I don't have valid consent under GDPR, well, this is flagging up that this marketing campaign has got an issue. And I can then drop down to the 3rd tier of the tool to see why that is. So here are these 3 processes. The top 2 are saying they're okay, as the visualization showed. So why is that? Well, in each case, both is consuming 3 pieces of data, and the process is claiming a contractual justification for that, which, given that one is a monthly payroll, and I probably have a contract with my employees, and the other is a customer billing process, and I probably have some sort of contract with my customers, that claim of contractual justification is probably reasonable. The 3rd one is this marketing campaign. This is saying actually that it's using 2 pieces of data, one of which I've got 90 items that I'm using based on data subject consent, and all of those items have got consent, so I've got 100% coverage, so that's fine. But then I have one rogue piece of data here, which is a marketing details database, which is being used based on data subject consent, but there is no consent for that data that matches this usage, or it's out of date. So that is flagged as being something that is being used illegally, and under GDPR, I'm in breach. Hence the tool is flagging that as an issue. So you can start to see here how graphs play into analyzing this know your data capability. So where is that data? I can look at, for instance, where I've got external organizations that I'm exchanging data with. I can understand what that data is. So you can understand it, the power of the graph, and it does 2 things. A, it allows you to collect those relationships. So this is, a lot of people try and do this activity of understanding their organization and their personal data using spreadsheets. It's an n-dimensional problem that's trying to be solved by a 2-dimensional spreadsheet, and it doesn't work. But you can see within a graph you have that ability to capture the relationships, to understand them, but also, having done so, to run analysis against the model to understand, you know, where have I got data that I'm not using. The model also captures things like security risk, it captures consent, so I can run queries against that to understand where have I got issues under GDPR, where have I got, you know, red or amber items, and then having done that, I can then look to see what I need to do to mitigate it. That might be another TrustUp module, but equally it might be that you go to your service provider and say, you know, what are you doing under GDPR? I need you to encrypt this database, or whatever it is. So I'm aware that we're sort of slightly running out of time here, so that was a very quick run through of TrustUp and the privacy lens. We have got contact details at the end of this, so if anybody's got any follow-on questions, please fire them to us.